Very grateful for the previous speakers. You really set the focus of today to showing this, that chemicals management and addressing hazardous chemicals can really drive innovation, and this is what is needed to produce for the future. As we heard also earlier, the first version of the SIN list was launched in 2008. And as has also been said since then, it has been able to do remarkable changes. It's been used much as a model and a base for discussion in regulatory purposes, both within the EU and also beyond. And it's also used by companies, procurement staff, and financial investors, as we will hear as well, in order to stay ahead of regulation. And since the first update, I think this was actually what Gert was showing on the different bars there. The first SIN list substances have actually been acted upon. Maybe not to the extent that we would have liked to see, but quite a few of them have been addressed. They are on the candidate list, or they have been put into other regulatory arenas. So why do we want to do another update now, we can ask. It looks strange. Well, the simple answer is that there are still so many hazardous compounds out there. They're in our everyday products, they're in our bodies, they can be measured in the environment, and many of them have not been addressed, at least not fully. And we have also discussed today the regrettable substitutes, and this is also what in the scientific community has been seen as so-called emerging pollutants. When measured in environmental samples or in humans or animals, you can see that some of these very old and well-known hazardous compounds are declining slowly, but still, while other chemicals, unknown chemicals, are rising. These are chemicals that are often used to substitute the so-called old SINs, but when looking closer to them, they often have similar structure and similar hazardous properties too. So this is what we want to address with this update. Quite a few of the new SIN substances are such regrettable substitutes or emerging pollutants. And we are also launching the Sinnovation tool, which is a help to avoid this regrettable substitution. So this update is all about guiding innovation for the future, and hence the Sinnovation title of today. Something's happening with my slides.
We can manage.
We can manage.
We've got a slight overlap. It's obviously a formatting problem.
It's not so important, I will tell you anyway. So how did we go about to find the new SIN substances? We started to try to identify possible substances that could qualify as SVHCs. As most of you know, I think the SIN list is meant to be to use exactly the same criteria as the REACH regulation and be a model for the candidate list. So we need to identify substances that could be identified as substances of very high concern and be relevant for the SIN list. And for this, we started to look into scientific literature. We looked at many reports of those so-called emerging pollutants. We looked at different reports. We looked at different authoritative lists, such as the COREP list, and also from different member states. We looked also at other lists from interest organizations, NGOs, and so on. And we also asked a lot of people what kind of substances they would like to see on the SIN list. And as I said, we did not start from scratch. So we started with substances that already were suspected of having hazardous properties. And we ended up by having more than 1,000 of those. So that, if anything, convinced us that we needed to continue to work with the SIN list and continue to address these chemicals. Unfortunately, we do not have the capacity to fully evaluate 1,000 substances. So we needed to prioritize this somehow. And for this, we used consumer use of the substances. This is quite difficult to identify. So again, we tried to gather different lists representing different sectors or different product categories. So we have, for example, lists representing chemical products, textiles, electronics, food contact materials, and the automotive industry. And what we also found very interesting was studies from the Danish EPA, where they have measured substances that are actually present in consumer products. So we used also the results from that to try to prioritize among this huge amount of substances. Since we do not fully cover all sectors here, some substances needed to slip through these filters anyway, but this was what we considered for our prioritization. So, what came out of this exercise were substances with different hazardous properties. But for quite a few of these categories, we found only a few substances, or we had the difficulties to find a lot of data. So again, we needed to prioritize our efforts. The most of the substances we found were in these two categories. They were suspected endocrine disrupting chemicals or potential persistent bioaccumulative and toxic chemicals. So we decided to go for these two categories, thereby not saying that we do not consider the other to be important or relevant for the candidate list, for the SIN list, but that's, at this moment, this was how we prioritized. And we are also very pleased to say that we were able to contract 2 excellent scientific teams to evaluate these substances for us. Again, we used the endocrine disruption exchange, which also evaluated the substances for a former version of the SIN list. This is a research organization founded by Professor Theo Colborn and now led by Karol Kwiatkowski, who will also explain more in detail what they did for us later. From Zurich, we contracted Professor Martin Scheringer, who looked into the PBT substances, the PBT, VPVB properties of the substances. And also he will present more in detail what they did for us. So based on these thorough investigations of these chemicals, it was in the end, again, us at ChemSec who took the final decisions on which substances to include on the SIN list. And we had very good advice from experts from a few member states, from research institutes, from scientists, and from NGO experts. And we discussed this much back and forth. We looked into research. We followed the latest political developments in the field to finally come up with substances that we are fully confident would fulfill criteria for substances of being very high concern and that are urgently needed to be addressed. When we looked at the SIN EDCs, we considered the following aspects of the compounds: that we could identify an endocrine mode of action, that we saw the potential of an adverse effect, and the link between these two. We ended up by putting 10 new endocrine disrupting chemicals on the SIN list, and these are the ones. You also have small summaries of them in your conference packages if you want to look at them more. We have, it's been said quite a few times already, I think, we have the bisphenols. We have bisphenol F and S that are used to substitute bisphenol A, sometimes, often in plastic products. We have a range of phthalates, 3 new phthalates, that we add on to the phthalates we already have on the SIN list. They are plasticizers, sometimes used in inks and prints, for example. We have ceram, which is a rubber agent. We have 2 substances where we found also data from humans, which is often difficult to find reliable data from. One of this is carbon disulfide, where it's been shown that human workers exposed to this have problems with the sperm quality, sperm count, and the same effects are also seen by this triphenyl phosphate, it's supposed to say, where exposure from normal house dust has been associated to decreased sperm quality. For the PBTs, we had a lot of information, very good information from the scientists, and we used a weight of evidence approach to use all available data, all available information on these substances. So we looked at measured data, experimental data. We looked at estimated data from models, which Martin will explain to you more. We looked at biomonitoring data, are these found in our bodies, in the environment? We looked at read across to structurally very similar substances, and we also looked at the degradation products. Do this substance degrade into something that fulfills the PBT criteria? And here we ended up with 13 substances. As you see, we have quite a range of fluorinated compounds. These are often used as surface treatment to make materials water repellent or stain repellent, for example. These ones have often been used to replace the more well-known PFOA and PFOS. And on the other side, we have quite a few flame retardants. The first ones are brominated, and the other ones are not. The last one there, the Chloran Plus, is a typical example of a substance that has been introduced to replace well-known POPs, which was among the first Stockholm Convention substances called Mirex. In addition to these substances that we evaluated ourselves, we have also added substances that have been officially recognized as fulfilling the criteria, since they have been recently classified as substances being toxic to reproduction, so CMRs. Those we don't need to further evaluate, but we put them on the SIN list as a technical update. So we have now 28 new substances for you to act on. We want the regulatory people, the policy people, to have a look at them, to bring them forward in the REACH process. We want the downstream users, the companies, to identify if and how you use these ones. Are they necessary, as Debbie said, and start phasing them out. And we want the producers to come forward with your alternatives, your well-investigated alternatives that are not regrettable substitutes. And the NGOs who are also here in the audience, you can do a lot by providing pressure on companies, on regulators on this issue. I thought I had another slide.
What would it have shown us?
I would like to say very much thank you, because this SIN list is not only ChemSec's work. We have an advisory committee of about 10 environmental NGOs in the US and in Europe that has been behind this work, that has been with us from the start, discussing the scope, into the very end of discussing the specific substances. So I wanted to say thanks to all of you, and many of you are here today.